I have a copy of the program we've been working on, the bash shell rather, that we've been working on. You can see that it is, let me see here. I have a link, a symbolic link to it here, but you can see this is the same program that's in our CDC 2024 repository. This is not the same version that's up in GitHub right now. As I've mentioned, I've made some modifications, and over the next week or so, week and a half, I'll be sharing more and more of what's in my code with you. But I do want to just show you how my version works. So if I go ahead and launch this, first thing you'll see is that I stuck with the grammar upgrades I made because I was so pleased with the way Dan responded to my dangling participles, or excuse me, prepositions. So I decided to expand on that. I did want to cut down on Dan's confusion though, so after the initial prompt here, oh, and Dan, I did say Dan is sorry, I am you too here so that you'd know. But by what string with which filtering the files this directory in, I did add the clarifying command type. So there are some files in here, some text files that make for a good use case. So I'm going to say I want to filter on the string txt in the file names. And after that, we get the second prompt, us, which field you data by sorting the files the screen on to be wanting to be, and then the clarifying command tell. And at first, we'll go through these in order, sorting by file name, then file name length, and then file name vowel count. And when we sort by file name, you can see this comes out correctly. But as you can see, we have digits first and then sorted alphabetical names after that. So we'll go ahead and reply to the prompt again, continue go to which for more for, and we'll tell it yes because we want to do this again. And this is just something I added to my program. I put it inside an infinite loop so that the user could go ahead and give repeated responses, and we could run the logic of the program over and over without having to exit and then start it again. So we'll go ahead and say yes to this. And the only thing that's implemented here is that if the user says yes, we go back to the top of the infinite loop. And if they say no, we issue a break command that would pop us out of the infinite loop. And at that point, we would exit the script. So we'll say yes. And that returns us to the original prompt by what string with which filtering the files this directory in type. And so we're going to stick with txt. And this time we'll sort by file name length. And this one's kind of fun because you can tell that the order is right by the way the file name column displays itself. So the question is just whether the counts are correct, the file name length itself. So if you're doing this on your own, a nice way to do is you can start and say, well, this one's 5, so this one must be 7, right? That's a lot easier. This one must be 10 because there's 3, whoops, because there's 3 more. So this one must be 12, 13, 14, and so on. We'll tell it again. I'm not going to read the silly prompts. Basically, this prompt is supposed to say, would you like to continue and do this some more? And we'll tell it yes. And this prompt is, of course, supposed to be saying what's the string you want to filter for. We'll say txt. What's the field that you want to sort the files by? And this time we'll say file name vowel count. And when we sort by vowel count, again, it's just a matter of validating that this is correct. We know that these file names, it's easy to look and just see those don't have any vowels. So these zeros, these zeros over here are correct. It says that the next one has 1 vowel, abc.text, pretty easy to check that. 1.2.my.file.text, the vowels are the I and the E in the word file. If we come down a little further, look for one that's a little shorter down here just to be lazy. Unfreeze.text has a U, a couple E's in freeze, and a third E at the end. and waka.txt has 4 A's, every other letter. And there are 5 vowels in I don't end with text.log. The I, the O in don't, the E in end, the I in with, and the O in log. So this is all counting correctly and displaying them in the correct order. So that's good. Those are straightforward things you can look at and just verify that, well, this is nice. My main logic seems to be working nicely. The file I use to build this simple column aligned list of data is called column. But let me exit out of the program here. Let's look at the Etsy password file. This is a file that shows the username. The X is a spot where there used to be a hash of the password that is not used anymore. 0 is the first number is the user ID. The second number is the, I believe, the group ID. I think this next field is the group name. The next field is the user's home directory. And this last field is the user's shell. When they log in, if they have a default shell, it will be put there. Well, this command column is nice. You can say you want to output it and build a simple table, and you can tell it that you want to use a delimiter. So if I wanted to, for example, get a nicer look at the Etsy password file, I could say cat Etsy password to the column command. I say I want to see a table, and by the way, the delimiters are colons. And if I do that, I get something out that looks like this. And so this will give you an idea of how I built that little display, right? Now the problem is I had the problem with having spaces as my delimiter is that there were spaces in the file names. I made sure I tested this by creating files with spaces in their names. That'd be the same thing as if Linux allowed you to create a user called Chris:*Leonard. It would kind of screw up the password file, right? Because now the delimiter would be part of the data as well. So that was a problem I had to solve that that we might go over as a kind of a bug. Also, you'll notice that I added headers on my output. So here's bash. Well, this text extension just is good, happens to be good test data, right? But I was able to add extensions and smart lengths of underscores under the headers. But after that, this is just output from the column command. And somehow I did something with delimiters that makes sure that things like this still work. And I'll even tell you this, it'll work with any file name that's allowed in Linux. Now what I'd like you to do though is just to look at this and say, okay, this is kind of what the program should look like. This is what the shell script should do. See how much of it you can get to work. The output doesn't have to look like this, but that would kind of be a maybe an advanced challenge. Can you use this output as specification after you get your program to work? Then can you go on and use this as a specification and get your program to output the same format? Another advanced specification would be, can you get it to run in an infinite loop like this and let the user continue as long as they would like to? This is the collection of keywords, commands, and symbols that I used in my script. So equal is a symbol, keyword, I guess it's not a keyword, it's an operator. And that's just for variable assignment, right? So I have places where I assigned variables. I don't have any place where I assigned a variable named first name and gave it the value Chris, but if I did, it would look like that. I use the base name command. Base name will take um, any file name that might have path information with it, and it will give you from that file name um, just the base name, just the file name itself. So if we look in here again at let's say this one, freeze.new.txt, which that's the base name, but it's inside the temp directory, right? So I can say, show me temp freeze.new.txt. And it says, okay, that's the file name /temp/freeze.new.txt. That's the file name. But if I say instead of seeing the full file name, I just want to see the base name. That's what this function will do. You say base name for temp dot or /freeze dot new dot text, and it will say, you hope, there you go, freeze.new.txt. So I used that command a couple of times to take file names and strip them down to their bare essential base name. I used break and just continue on here. There's some other loop control I thought, but I use break to unconditionally exit loops. Those loops are while loops and select loops. Select the menu command or the menu structure select has a do loop inside of it. The column command I just showed you, it makes the output look nice. I used echo. You know about echo. We use it to put information on the screen. Exit is used to unconditionally exit a script. I used find instead of ls. I used grep, the search command, to find vowels. I said, I'm going to look at these file names and I want you to find the A's, E's, I's, O's, and U's. And then I used word count to count the vowels. You might have to think about how I made that work. There are places where I used the if construct, if then elif phi or phi, or fo or fum, I know. And that's obviously for conditional logic. I did use a temp file, as you saw in those 3 lines of source code that I leaked. And that will make a temp file and it returns the name of the thing. So that's how you get the name of the file. You generally run it and store whatever it returns in a variable rather, and then you can use the variable as though it were a file name. Read, you'll remember we used that to prompt the user for input. RM is used at the end to get rid of whatever file name I got from maketemp. I want to delete it just to be a good citizen and clean up after myself. Select is here with its do done loop, and that's how we display those really simple menus. While is on here is the other looping mechanism, while do done. That's what I use to drive the infinite loop for the user. And the last one, we've already talked about WC, so the last one is sort. And sort is actually the command I use to show the data. I do pipe the output of sort through the column command, but by the time I'm ready to show the data, I've got it staged in that temp file, and I've looked at the user's options, and I have things set up so that there's one sort command that runs, and it's the same sort command no matter what the user's asked for. So that's one thing about programming, is that sometimes one hallmark of a good program, a good script, is that if you think hard enough about what you're doing early on and you organize things well, when you get to the part of the program where you need to make something happen, once you get there, it's a good sign if all of a sudden you're like, oh wait, now all I have to do is this one thing. And for me, I knew I had done a good job with part of this because I got here and it's like, oh wait, if I take this one additional step, I'll just have this one sort command that'll work for all of the use cases. So that was a good sign to me that I had at least done some things well. So that's where we are right now. You've seen what my shell script does. You've seen these keywords, commands, and operators that I use in my script, and we'll move forward from there. So I really hope that you guys will work on yours as you have time. Certainly not over the holiday though. It's the 22nd right now. It's going to be the 23rd in 12 minutes, and I hope that you guys have a good time with your families. I know that some of you are really not so much looking forward to driving 4 hours to spend 3 hours with somebody and then drive 4 hours back or whatever, but still, I hope you get to enjoy the time that you have with people and maybe enjoy some conversations or just hanging out or goofing off with people in ways that you didn't expect to enjoy. So I'll look forward to seeing you guys again. Let me know if you have any questions about all of this, and we'll talk to you later. Thanks.